Here we're given two vectors, and we're asked to show that u cross u is equal to 0. So I'll write 1, 1, minus 1, there's u, and then right beneath it, 1, 1, minus 1. And then remember the cross product, covering up the first two, I get negative 1 minus a negative 1. So taking the cross product, I get negative 1 minus a negative 1. And then covering up the middle one, I get negative 1 minus negative 1. So I get minus negative 1 minus negative 1, because remember the middle one's negative. And then the last one, covering up this, you get 1 minus 1. And if you work all of those out, you get 0 minus 0, 0. That's the 0 vector. Then it says to find u cross v. Well, do it again. 1, 1, minus 1. This time we got 2, 1, 2. And it is important that you write the top, the u on the top, v on the bottom, otherwise you get the wrong sign. But if I take this cross product, covering up the first two, I get 2 minus a minus 1. That's going to be 3. Covering up the middle, I get 2 minus a negative 2, so that's actually 2 plus 2, but remember the middle one's negative. Then covering up the last two, I get 1 minus 2, that's negative 1. And I can quickly check, because I know this is perpendicular to both of them. So I can see 3 times 1 is 3, negative 1, 4 times 1 is negative 4, negative 1 is 1. So 3 minus 4 plus 1 does give me 0. You can check them on both. I usually, if you check it on one and it works, it's probably okay. So there's my cross product. I think I got it calculated right. Then it says find the area of the parallelogram formed by vectors u and v. And I know that I've already done the work other than finding the magnitude of 3 minus 4 minus 1. That will be the area, the magnitude of that cross product. And so that will give me the square root of 9 plus 16 plus 1. That's the square root of 26. All right, and then number 8. Which of the following does more work? A 10-pound force acting on an object at an angle of 0 degrees, meaning in the direction of motion, which displaces that object by 10 feet, or will I get more work by applying a 20-pound force acting at an angle of 45 degrees above the horizontal, displacing an object 10 feet. Okay, so first situation, you've got some object, you're applying a force, and you're getting a displacement, but the force is going in that same direction as the displacement, and your displacement is, what I say, 10 feet. Well, in this case, the amount of work is just force times distance. And this isn't a dot product, this is just multiplication, force times distance. The force is 10 pounds. You've moved it 10 feet. So 10 times 10 is 100 foot-pounds. Okay. Now, the second one, I'm applying the force at an angle, and it's a 20-pound force that's being applied, and this time I'm displacing it still 10 feet, but this is at an angle of 45 degrees from the horizontal. Okay, so in this setup, remember we derived that the total work is going to be, it's a dot product, but you can't quite just go straight to the dot product unless you find the force vector itself, but it's the magnitude of that force vector times the magnitude of the displacement times cosine of the angle between the two. And since this is going horizontally, that angle is 45 degrees between these two. So there's my force vector, my displacement vector, and we'll put in the parts that we have here. Well, we know the force that I'm applying is 20 pounds. The displacement is 10 feet, and the angle is 45 degrees. Now, you got to remember cosine of 45 degrees, that looks like 450, that's 45 degrees. You know, if you draw 45, 45, 90, or if you got it memorized, whatever, but the sides are 1, 1, square root of 2 in that ratio, and cosine is adjacent over hypotenuse, it's 1 over square root of 2, or if you like, square root of 2 over 2. So 1 over square root of 2, which you rationalize to get square root of 2 over 2. So I get 200 times square root of 2 over 2 foot-pounds, but let's first calculate, canceling that out, you get 100 times the square root of 2 foot-pounds. So the answer is you've done more work to do this problem, the second problem, where you're displacing it 10 feet pulling at an angle but applying a 20 pound